Assalamu alaikum. I am Muhammad Farghali. Welcome to a new episode of a Paper in 10 Minutes series, visualized by 4D Geosteering.
Hello, everyone. Welcome back to our ongoing expedition into the realms of practice and understanding of side-tracking horizontal drilling in old wells in Sulige gas field, northwest China. Don't miss out on our first episode that revolutionizes unlocking reservoir potential while addressing challenges. Catch it now for an exhilarating exploration. Let's delve into the depths of key technologies for side-tracking horizontal wells from old wells. Firstly, we talk about drilling technologies for small borehole sidetracking problems. The first point, slim hole integrated window opening technology. The initial stage, a drilling template of 139.7 millimeters casing sidetracking horizontal well. The window opening point conforms to the well profile design and is beneficial to the trajectory control of the open hole section. By using the self-developed Phi 118 mm integrated high-efficiency window opening tool, the window opening can be completed in one trip. The second point, slim hole drilling speeding up technology. Tailor-designed PTC bits with optimized crown shape for enhanced drilling, reduction in drill coupling size to minimize annular circulation pressure loss, carefully selected small-size screws improving compatibility and extending usage, optimized drilling tool combinations and parameters for enhanced performance, the use of bubble stabilizers in the horizontal section for improved angle holding, balanced displacement, pump pressure, and cutting carrying capacity to prevent blockage. The third point, well trajectory control technology, adjustment of drilling tool combinations based on formation variations and different well inclination stages, and the deviation of the actual drilling trajectory from the design is analyzed constantly to predict the build-up rate of the next step and enables timely trajectory adjustments. The last point, drilling fluid technology. Polyamine inhibitor plus potassium chloride system, selected to address mudstone collapse, circulation loss, and back pressure. Secondly, we talk about optimization of side-tracking horizontal well deployment. First, we talk about study on remaining reserves distribution, seismic waveform indication inversion technology. This method, along with spectrum attenuation gas detection technology and reservoir logging evaluation, are utilized to predict inter-well gas content and track sand bodies to establish a more elaborate three-dimensional prediction model. Stochastic simulation technique. By integrating geological, seismic, and logging data, this technique establishes a three-dimensional reservoir parameter model. The simulated production data, including gas well pressure and production rate, show a conformity of 95%, highlighting the reliability of the simulation and its contribution to the success rate of well deployment. Analysis of production characteristics. By analyzing the production characteristics, production capacity, pressure drop, and well test data of adjacent wells, reservoir productivity, gas well control radius, and remaining reserves range are determined. Second, selection of site tracking horizontal wells. The selection process adhered to specific principles and considerations. Firstly, reservoir characteristics. Emphasis was placed on reservoir connectivity, gas saturation, interlayer thickness, and stability of reservoir distribution. Vertically, reservoirs with effective thicknesses exceeding 8 meters and high gas saturation were prioritized. Secondly, geological features. On a planar level, layers with rich remaining gas, good gas-bearing response on seismic data, confirmed structures, stable reservoir distributions, and the thickness of sand body tracked in horizontal sections greater than 3 meters are selected to ensure a high drilling rate and a good wellbore trajectory and reduce drilling failure. Thirdly, base well criteria. Base wells were selected based on their reserve bases, recovery degree, and proximity to adjacent wells. Additionally, base wells with low recovery degrees and minimal production were favored. Moving on, optimization of side-tracking horizontal well parameters. Horizontal section, azimuth. Numerical simulation results show that the development effect is the best when the horizontal section is along the main channel. The horizontal section length controlled between 600 to 800 meters to minimize construction risks and optimize gas production increment versus operational cost. Longitudinal position. The horizontal section should be located in the middle of the target layer to maximize reservoir production from surrounding layers. Let's delve into the depths of geosteering technology for side-tracking horizontal well. Side-tracking horizontal wellbore trajectories pose challenges in control compared to conventional wells due to the risk of facies changes and potential drilling out of the reservoir. Strengthening geosteering studies is crucial to enhancing reservoir drilling rates. Guided by geological research, various prediction methods, such as seismic processing and modeling, were employed to establish microstructural models and analyze target layer attitudes for trajectory anticipation. Stratigraphic correlation with adjacent wells was intensified using logging curves to enable timely well trajectory adjustments for precise target landing. Predictions of bottom lithology were made using drilling time, torque, sedimentary cycles, cuttings grain grading characteristics, and formation deflecting ability, despite the measuring instrument's blind zone. Let's delve into the development effect of side-tracking horizontal wells in Sulige gas field. From 2011 to 2017, a total of 12 side-tracking horizontal wells were drilled in Block SU-10 and SU-53. During this period, the drilling cycle was significantly reduced from the initial 90 days to approximately 40 days, with an average of 49 days. From 2011 to 2017, 12 side-tracking horizontal wells were drilled in Block SU-10 and SU-53, with gas saturation showed variability ranging from 40.6% to 75.9%, with an average of 56.5%. The controlled reserves were estimated between 3,180 11,943 times 10 to the power of 4 cubic meters, with an average of 6,438 times 10 to the power of 4 cubic meters. Before sidetracking, the average daily gas production per well was less than 0.1 times 10 to the power of 4 cubic meters, and the cumulative gas production was 568 times 10 to the power of 4 cubic meters. Following the implementation of side-tracking horizontal wells, the average initial wellhead pressure was recorded at 16.2 megapascals, with an average initial gas production of 4.7 times 10 to the power of 4 cubic meters after putting into production. Correlation analysis revealed a positive correlation between the initial daily gas production and the produced effective gas layer thickness and length of sandstone segment and controlled reserves. Notably, it was observed that when the initial daily gas production exceeded 4 times 10 to the power of 4 cubic meters, there was a clear positive correlation with the cumulative gas production of old wells and with controlled reserves. The deployment of a side-tracking horizontal well based on SU-53 FCH, SU-53F, located at the edge of Block SU-53, proved successful. Consequently, a side-tracking horizontal well was deployed based on SU-53F, with the design including confirmation of reservoirs in horizontal sections A and B, each spanning 700 meters. To avoid interference between wells, the azimuth of the horizontal section was adjusted from south by east 20 degrees to south by west 20 degrees. SU-53 FCH was successfully drilled in 2017 with a drilling cycle of 34 days, a sand drilling ratio of 97.8%, and a drilling ratio of effective reservoir of 92.1%. The horizontal section has an effective thickness of 11.5 meters, with controlled reserves estimated at 11,943 times 10 to the power of 4 cubic meters. Upon production commencement, the well demonstrated an initial pressure of 20 megapascals and a daily gas production of 11 times 10 to the power of 4 cubic meters, showcasing remarkable production increase. Embark on a journey. We unravel the development direction of side-tracking horizontal drilling of old wells in Sulige gas field. Firstly, we talk about well pattern planning innovation. Side-tracking horizontal wells have the advantages of low cost and selective development, but currently limited by the basic well pattern. This measure can only be taken in the limited area. When the block is expanded or deployed step out, a side-tracking horizontal well pattern can be planned to make use of its advantages. Side-tracking horizontal well infilling can be used to enhance reserves exploitation, or the horizontal well can be deployed directly in the adjacent area at a later stage. If the reservoir is found thin by drilling a vertical well, making it difficult to drill side-tracking horizontal wells, infilled vertical wells can be taken later on. Therefore, according to the distribution characteristics of different reservoirs, the mixed pattern of horizontal well, side-tracking horizontal well, and vertical well can be selected. Secondly, we talk about optimization of side-tracking horizontal well construction and parameter. The research of drilling and completion technology should be strengthened, and bit, drilling tool and drilling fluid system should be improved constantly to lower the difficulty of side-tracking horizontal well construction, shorten the drilling cycle, and reduce the costs. Thirdly, we talk about expansion of side-tracking horizontal well application in the overall development area of horizontal wells. According to the utilization of reservoirs, gas-bearing condition, interlayer condition, and adjacent well utilization of remaining unproduced reservoirs should be examined. If there is potential for separate layer development, a double-branch side-tracking horizontal well can be tested to explore side-tracking stimulation technology based on horizontal wells. As we reach the conclusions, let's reflect the pivotal role of our research. The development of side-tracking horizontal drilling in old wells in Sulige gas field has progressed through 4 stages. It has proven to be an effective measure to increase the production of old wells. Side-tracking horizontal wells significantly reduce development costs and tap into remaining reserves between wells, while offering more certain reservoir geological conditions. Key technologies in drilling and completion: reservoir distribution research, area selection, parameter optimization, and geosteering, effectively addressing the challenges in side-tracking drilling and enabling large-scale application. In Block SU-10 and SU-53, 12 side-tracking horizontal wells were drilled, resulting in a significant yield increase. Production from side-tracking horizontal wells correlates positively with effective gas reservoir thickness, length of sandstone segment, and controlled reserves. Side-tracking horizontal well technology can evolve in innovative well pattern planning, optimization of well pattern layout and design parameters, testing of long horizontal sections, large displacement, and expansion of application areas. Join the conversation. Leave a comment sharing your thoughts or questions, and don't forget to share this video with your network. Also, follow my LinkedIn profile for additional insights.